Hello, I am Sunita. Welcome to my class. Here I am going to discuss GPSTR science topics according to the syllabus. Here the topic is Newton's law of motion. Galileo Galilei, he is a famous scientist. He performed several experiments when it is in motion. Then based on the Galileo experimental observation, Newton introduced three laws of motion. In this class, let us study in detail Newton's laws of motion and also Galileo experiments. Let us study about Galileo experiment in detail. Galileo did so many experiments when it is in motion. Let us consider here the inclined plane. If you roll the ball on the inclined plane, then the ball it will move downwards. Then the velocity of the ball it will be increases as the ball is moving downwards in the inclined plane. Then consider the second case. Here if the ball move up on the inclined plane, then the velocity it will be decreases. Then here consider two inclined plane here. Then leave the ball edge at one height of the inclined plane. Then the ball it will move downwards. Then it will start climbing on the second inclined plane. Then here if the angle of inclination on both the plane, if it is same, if the angles of inclination on both the planes if it is same, then the ball it will covers equal distance in both the planes, and also it will reaches equal height on both the planes. That one you have to remember. Galileo experiment. Here consider two inclined planes here. If angle of two inclined plane theta if it is same, then the ball it covers equal distance to reach an equal height. Here consider the first case here. If angle of second inclination theta 1 if it is less than theta means angle of first inclination. If theta 1 is less than theta, then this second inclination, this ball it has to cover more distance d1 it will be greater than d to reach the equal height. Then here you can observe the second inclination plane, the ball it has to cover more distance to reach the equal height in both the planes. Then here consider if theta 2 is still less than theta 2 is the angle of second inclination plane, theta is the angle of first inclination plane. If theta 2 is less than theta, then here the ball it has to cover more distance in the second inclination plane to cover the equal height, otherwise to reach the equal height. If you remove second inclination plane, then if you move the ball downwards in the first inclination plane, then here you can observe the ball after reaching the ground it will start moving in a straight line. Angle of inclination here 0. This ball continuously it will not move. After some time it will stop because of the frictional force. Frictional force is nothing but when a body when it is in motion, then the opposite force it will be restrict the motion of the body. That force we will call it as a frictional force. When the ball is moving in this direction, in the opposite direction, frictional force it will be acts on the body. Frictional force is the opposing force, it will oppose the motion of the ball. Therefore due to the frictional force, the ball after some time it will stop. Then here if the surface is smooth surface or oil surface, frictional force is less, because the smooth surface, oil surface, the motion of the body smoothly it can move. Even though friction is there, smoothly it will move, but the frictional force is very less if the surface is smooth surface or oil surface. First law of motion or law of inertia, another name is law of inertia. Body remains its state of rest or uniform motion along a straight line until and unless an unbalanced force acting on it. Assume if this is the football, this football it will be at rest if you not applied any force or unbalanced force. Assume the football it is moving without any disturbance, it will be continuously moving. Then if you apply a unbalanced force, then it will stop, otherwise it will move fast. Then change in speed or velocity, it will be depends upon whether you are applying an unbalanced force or not. This one we will call it as a Newton's law of motion. Let us discuss in detail Newton's first law of motion with an activity. Procedure: take a few coins of same size, arrange them vertically on each other above the smooth surface. Take some coins having the same size, arrange them one above the other on a smooth surface. Next, take another coin and give a sharp hit at the base of the pile. Record your observation. Take another coin, then with that coin, then give a hit at the base of the pill. Only at the base you have to apply a force. Then what you will observe? Then by this coin only the base coin, why it will move, let us discuss here. Hit of coin applies force on lower coin. Due to this, lower coin gains motion, hence change its position. You are applying a force, otherwise you are applying a pressure on the lower coin. Due to your force, the lower coin only it will move. Then the remaining coins you are not applying any force, they will be at the state of rest. Then this lower coin, it will be change its position. All the coins present above the lower coin experience a vertical fall. The remaining these coins, they will be at rest. Therefore, they will feel vertical fall as they try to maintain their state of rest, because the remaining coins, they are maintaining the state of rest. Therefore, they will come down, vertically fall at the same position. But you are applying a force on the base coin, therefore only the base coin it will move. From this experiment you can conclude, when the object, when it will be at rest, if you are not apply any force on that object, it will be at rest only. As these coins, they will be at rest only. Only you are applying a force on the lower coin, the force applied by the lower coin, therefore the lower coin it will move to a certain distance. Let us discuss one more activity to describe the Newton's first law of motion. Procedure: take a coin and place it on a rigid card. Now place them all together in an empty glass. Take a coin, place on a rigid cardboard sheet, then place all together on a empty glass. Then give a sharp strike to the card such that the card shoot away. What you will notice? Then give a sharp strike to the card that the card shoots away. Then what you will observe? Let us discuss here. Then here, strike on the card, apply a force on card which provides it with the motion. When you strike the card, then the card it will acquire a force. Because of the force, the card it will be start moving, otherwise it will shoots away. Then hence the card shoots away, coin present on the card falls into the glass in order to maintain its state of rest. But the coin it will falls into the glass in order to maintain its state of rest, because you are applying a force only on the card, you are not applying a force on the coin. When you applied a force on the card, then the card it will shoot away, but the coin it has to maintain its state of rest, therefore it will move down. These are the best example of Newton's first law of motion. Let us consider next activity 3 to discover the first law of motion. Procedure: take water filled glass in a tray, then take a fast turn by holding tray along with a glass of water. What you will notice? Then you have to hold the tray. Then you have to take a fast turn by holding the tray along with a glass of water. What you will observe, let us discuss here. Initially, water in a glass is at rest position. Initially, the water it will be at rest position. When you take a fast turn, then force from a air is applied on a glass, but water is in rest, because the force from the air it will be applied on the glass but not on the water. In order to maintain its state of rest, water from a glass spills. The water it will be in the state to maintain its state of rest. Water from the glass it will spills, because when the force from the air it is applied only on the glass, not on the water. Therefore, the water it has to maintain its state of rest. To maintain its state of rest, a the water in the glass, it will spills out. From the glass it will spill out. Let us discuss the relationship between inertia and mass. Inertia and mass are directly proportional to each other. As the mass increases, inertia also it will be increases. Here consider this box. The mass of this box, it will be less, therefore smaller inertia. Then compare this mass of the box compared to this one, it is much more bigger, therefore this box it will possess larger inertia. Then compare the inertia of bicycle with inertia of train. Bicycle, because of small mass, it will possess smaller inertia. Then train, because of bigger mass, it will possess bigger, otherwise larger inertia. Therefore, inertia is directly depends upon the mass. As the mass increases, inertia also increases. Let us study Newton's second law of motion. Definition of second law. According to Newton's second law of motion, the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. Force is directly proportional to change in momentum divided by time taken. According to Newton's second law of motion, F is directly proportional to change in momentum divided by time. Then F is directly proportional to final momentum minus initial momentum divided by t, because always change in momentum is nothing but final momentum minus initial momentum. Therefore, F is directly proportional to, you know the value of P is equal to m into V. Therefore, final momentum is m into V minus initial momentum m into U. Take m as a common, then m it will be equal to V minus U. Therefore, F is directly proportional to m into V minus U divided by T. To remove this proportionality, put a proportionality constant here. Here k is the constant of proportionality. F it will be equal to k into m into V minus U divided by T. Then according to the definition of acceleration, you know acceleration is nothing but change in velocity divided by time. Change in velocity is nothing but final velocity minus initial velocity divided by t. Then substitute a value in this equation, then you will get F it will be equal to k into m into a. Here unit of force is selected in such a way that the value of proportionality constant k can be taken as a 1. If k is equal to 1, in that case F is equal to ma. These are the mathematical derivation of Newton's second law of motion. Newton's second law of motion, you know the mathematical formula F is equal to m into a. Then here according to the formula it will indicate acceleration, it will be depends upon mass, acceleration depends upon even force also. But here one thing you have to identify, acceleration is inversely proportional to mass. As the mass increases, acceleration decreases. As the mass decreases, acceleration increases. Then next one, acceleration is directly proportional to force. As the force increases, acceleration increases. As the force decreases, acceleration decreases. Here let us verify this one with an example. Here consider a boy, he is carrying a cart. Then here first case, this is the empty cart. Second case, the cart containing some amount of some weight, otherwise some amount of things, some items. Then the cart, that this one also it contains some amount of weights or items. Then here if the person, if he want to push this empty cart, easily he can push, because this cart, the weight of this cart, otherwise mass of this cart is less. Already you know, when the mass is less, acceleration it will be more. Then easily this boy, easily he can push the cart when it is empty. In the second case, if the cart contains some items, otherwise it carries some mass, then this boy, it has to exert some force. Then acceleration compared to the first case, it will be less in the second case. Then here in the third case, you can observe The person, if he push the cart with higher force, otherwise larger force, then the cart move, it will be fast compared to the first and second case, because already you know force is directly proportional to acceleration. As you apply more force, acceleration it will be increases, then the cart it will move fastly. From this one you can conclude acceleration depends upon both mass and force. Newton's third law of motion. For every action, there is an equal and opposite reaction. Consider the gun here. When you fire the gun, then the bullet it will come out of the gun with some amount of force. Then at the same time you can observe the recoiling of the gun, means the gun it will move backward with some amount of force. The force it will be in this direction. Therefore the bullet coming out of the gun it is a action, then recoiling of the gun is a reaction. Therefore action and reactions are the two forces, but they are in opposite direction. You can observe these two are the action and reactions are the two forces, but they are in opposite in direction. Here one thing you have to observe, the mass of the bullet is less compared to the mass of the gun. Therefore the bullet it will exert more acceleration compared to the gun, because mass of the gun is more. You know, acceleration is inversely proportional to mass. As the mass increases, acceleration decreases. Therefore action and reactions are two forces. They are in opposite direction but equal in magnitude. This case you have to remember, not necessary acceleration produce same magnitude. That one you have to remember. Let us discuss Newton's third law of motion with an activity. Take an air-filled balloon and tie its neck to avoid the release of air. Take an air-filled balloon and tie this neck to avoid the release of air. Now attach a straw with balloon using a tape. With the help of the tape, attach straw and balloon. Pass a string through a straw. Then take one string, pass the string through the straw. Then attach both the ends of the string through a rigid support. Then attach both the end of the string to a rigid support. Now open the neck of the balloon. Then open the neck of the balloon. Then what you will observe, let us discuss here. Removal of thread allows the air inside the balloon to escape. When you remove this thread, then it will allow the balloon air to escape from the balloon. Straw moves in the direction opposite to that of the air. Then the straw it will move in this direction opposite to the direction of the air, which shows the motion of balloon in opposite direction. Therefore the balloon it will move in this direction. Hence it satisfies the Newton's third law of motion. Then the air coming out of the balloon, that is the reaction. The balloon it will move backward, that is the action. Otherwise the straw it will move backward, that is the action. Then the air it will come out from the balloon, it will be the reaction. Then here you can observe every action there is an equal and opposite reaction. Let us discuss one more example here, flying of birds. The bird's wing it will exert force on the air. Therefore wings push air downward. Therefore the wings it will push the air downwards. At the same time this air it will exert force on the wing. Then air reacts by pushing bird upward. Because of this air exert force on the wing, then it will push the bird upward. Therefore here also there is an equal and opposite reaction. Thanks for listening my class. Send me your valuable feedback.